In topic 7.7, we're going to be talking about acid rain or acid precipitation or acid deposition. All of those terms generally mean the same thing. And acid deposition, that's the term I'll generally use, is the primary pollutant that is released into the atmosphere are nitrogen oxides and sulfur dioxide. And the source of those pollutants, the reason that they get emitted into the atmosphere, are generally due to the burning of fossil fuels. Sulfur comes mainly from the burning of coal, and as we talked about previously, different types of coal have different amounts of sulfur in them, and so burning high sulfur coal contributes more to acid deposition. The nitrogen oxides also come from the combustion of coal, but also from vehicle combustion. The burning of gasoline is an important contributor to those nitrogen oxides. And what happens is when sulfur dioxide and nitrogen oxides are released into the atmosphere, they are transformed, they combine with water through chemical reactions to form secondary pollutants. And these secondary pollutants are the pollutants that form acid rain or acid deposition. The sulfur dioxide combines with water, it forms sulfuric acid. The nitrogen oxides combine with water and form nitric acid. And as we already know when we talk about acids, acids contain higher concentrations of hydrogen ions. And so when those secondary pollutants are formed in the atmosphere, they eventually fall to the earth in acidic precipitation, rain, snow, or they can fall as dry deposition as well. But those forms of acid deposition have a low pH, a lower pH than typical normal rainwater. Normal rainwater is slightly acidic, has generally a pH of around 5.6, and that's because it has carbon dioxide dissolved in it, and that forms carbonic acid. So typical unpolluted rainwater has a pH of 5.6. When we start to move well below that, then we have acid rain. Acid deposition, those secondary pollutants, as they fall to the earth, can have a variety of effects on ecosystems. And so we can see this map gives us some information about where there's the most acidic precipitation. It's generally in the northeast and the east coast, in the Midwest. These are areas where the pH of the rainwater is lower than other parts of the country. And as this acidic precipitation or snow or dry deposition, as it falls on ecosystems, it can have several different effects. And so when it falls on aquatic ecosystems, ponds, lakes, streams, it over time decreases the pH of those bodies of water. And if it brings them down below a level where organisms that live in those lakes and streams can tolerate, then they can no longer survive there. And different types of organisms have different ranges of tolerance for acidic conditions. For example, snails and clams are quite vulnerable. They do not have a wide range of tolerance in terms of pH. If the pH falls below a pH of around 6, then they can no longer survive in those conditions. Other organisms might be more tolerant, as we see in this data table on the right. But as these bodies of water, these aquatic ecosystems become more acidic, then fewer and fewer organisms can survive, and this obviously impacts other organisms because of the interrelationships in ecosystems, because of food webs and food chains and nutrient cycling. In terrestrial ecosystems, acidic deposition, acid rain, can do several things. As soil becomes more acidic, aluminum ions become mobilized. They become soluble and can be then taken up by trees, and they can be damaging to the tissues of plants. They can also interfere with the absorption of calcium and magnesium. Acidic precipitation can leach those nutrients, which are important for producers, from the soil. It can lead to a reduction in cold tolerance for certain species. One species that is vulnerable is red spruce. There are large forests in more northern latitudes and at high elevations of red spruce forests, and they are vulnerable to the effects of acid deposition. The needles of red spruce, the calcium from them can be leached out. They can be damaged, reducing photosynthesis and also reducing their tolerance to cold and freezing. So this acid deposition can have a variety of negative impacts on organisms in both aquatic and terrestrial ecosystems. Another phenomenon that happens sometimes is in colder areas as snowpack builds up in the wintertime. If that snow is formed from acidic precipitation in the spring, when it melts and runs into streams and lakes and ponds, then it can cause a sudden shock, a sudden drop in pH, which can have an important effect on organisms. Acid precipitation also affects human structures, building materials. Things like statues of marble or limestone can be eroded quite quickly by more acidic precipitation. We also know that pollutants like sulfur dioxide, nitrogen oxides can travel very long distances. Oftentimes, especially in power plants or manufacturing, when you're burning fossil fuels, smokestacks to release the emissions are built very, very tall, and they can actually put the emissions, put that air pollution up high into the atmosphere, into the troposphere, and then wind currents can take that and actually move those pollutants hundreds of miles away. So often what we see is the place that is burning these fossil fuels and producing this pollution is actually not the community that's most affected by the results because of the wind taking these pollutants quite far away. It also makes it more challenging to regulate at a state level these pollutants because they don't adhere to state boundaries, and so generally to manage and regulate these emissions we need a federal policy, federal mechanisms to reduce the emissions of those pollutions. Also, different soil types are more or less vulnerable to the effects of acid precipitation as well. Soils that are rich in limestone, or soils that have come about from limestone as the parent material, are more basic generally, and that material can then neutralize some of the acidity from this acid precipitation. Other soil types are more vulnerable, or thin soils cannot buffer the effects of acid deposition. So depending on the type of soil can have an impact on how bad the effects of acid precipitation are. But there is some good news here. If we look at these two images at the bottom of the slide, in 1990, as we talked about when we talked about the Clean Air Act, an amendment to the Clean Air Act was put into place that instituted the cap and trade program on sulfur emissions. And so since that time, we have had a significant decrease in sulfur emissions and subsequently a reduction in acid deposition. We can see here after the Clean Air Act was enacted, there was a decline in sulfur emissions up to 1990, but after the cap and trade amendments to the Clean Air Act, we see a really drastic decrease in sulfur emissions. So they've been cut quite a bit. And if we look at acid deposition over the last 20 years or so, this is the total sulfur deposited, we can see that this reduction in sulfur emissions has resulted in a reduction in sulfur deposition quite significantly in the United States. We could see some more data. This is a little bit more local for us. So this data comes from Whiteface Mountain. If you've ever been to Whiteface or hiked or skied on Whiteface, at the very top is an observatory where they collect data. And they've been measuring acidic precipitation for 25 years there. And so there's two sets of data here. The pH of the summit, the cloud water and the precipitation, and also the nitrogen and sulfur levels of that in the atmosphere. So what we can see, again, if we compare from 1994, I guess, that at the summit, nitrogen levels in the atmosphere have gone up and then decreased since around 2005. If we look at sulfur, we have a more significant, there was never any increase, but just a gradual decrease in sulfur. And so if we look at what happened to the pH at the summit, the precipitation pH has gradually increased and become less acidic over time, and the cloud water has also become less acidic. So we see progress once action was taken to help mitigate some of these impacts from acid deposition.